So thanks for joining us today. My name is Sean Maurer. I'm the technical director here at the Smart Energy Design Assistance Center. Today we're going to be talking a little bit about collection system improvements and energy efficiency. Um, so let's just go ahead and get rolling. First, a little bit about who we are here at CDAC. Get my slides moving there. We are an applied research program here at the University of Illinois with the goal to reduce the energy footprint of Illinois and beyond. Um, So we assist buildings and communities with achieving energy efficiency, reducing energy consumption, saving money on their utility bills, and becoming overall more sustainable. We partner in this program with the Illinois Sustainable Technology Center, who has a similar mission, a little bit more scope. If you see Bill in the chat, he'll say hi and drop a couple of comments in the chat for everyone. But we both work with the Illinois EPA Energy Office to provide no-cost energy assessments for public water and wastewater treatment facilities. And we also provide these educational training events a few times throughout the year. Upcoming in May, we are going to host a field day. We are going to be touring an algae wheel process at the Bookwalter Woods Mobile Home Park near Gardner, Illinois. Just as an example of algal treatment processes, we're going to talk about applications for this type of process, for nutrient removal, the benefits of some of the things you can get some side stream income from harvesting the algae off these processes. So if you're interested in that technology or its applications, how it could apply to either your facility or maybe if you're looking into some distributed treatment, if you've got some additional developments being added onto your system, maybe this could be a way to help boost treatment capacity. Then please do come out to that field day May 15th. We're working on locking down the location to host our workshop meeting, and then we'll be going on site to look at this algae wheel treatment process. A little bit about our program here with the Public Water Infrastructure Program. Again, we are partnered with the EPA Energy Office to provide no-cost energy assessments. As part of that assessment, we'll come out to your site. We'll spend a couple of hours there reviewing your facility, taking pictures of equipment, documenting conditions and things like that so that we can develop a comprehensive report for you. That report will contain costs of upgrades, estimated payback periods, energy savings potential, and all the information we can find on applicable incentives and funding opportunities to help you implement those projects. And then also, as today is an example of, we continue to offer continuing education credits for operators. Why might you want to complete an energy assessment? If you have an older existing system or you've never had an assessment before, we can find missed opportunities, help you plan for future capital improvements, provide third-party support for ideas that a lot of operators already know what kind of upgrades their facilities need. So we can start helping you develop a way to justify that for budgetary support. If you have a new or recently upgraded facility, budgets are always strict and tight. We can find out what may have been left on the table. Maybe there's some alternative or new technologies that have come out recently that might be applicable to your system. So we'll go through those different options and things and find what might still be available for you to improve your efficiency. So how to apply for that assessment process? Apply at smartenergy.illinois.edu/water. For this program year, we've only got a few slots left. So if you're interested, please do sign up and get involved in the program. You must be located in Illinois and be publicly owned. You're going to have to agree to allow us to come out to the site, document information about your facility. We're going to be gathering utility information and your discharge monitoring reports. If you're a water treatment plant for potable water, then we're going to need to gather monthly operating reports from you as well. That way we can benchmark your facility, let you know where you stand relative to the other facilities that we've assessed in the state, give you an idea of what kind of potential savings there is. Once all that information is gathered and complete, then we'll schedule a site visit with you. Again, that site visit takes a couple of hours to go through the facility, document what's going on, what upgrades you'd like to see, and then we'll come back to our office, and generally within 6 to 8 weeks, we'll generate a report and get that back to you. So today's presentation, we're going to be talking about collection system improvements. Joe Sullivan is joining me today from Robinson Engineering. He'll be talking a bit about inflow and infiltration, and then I'll come back and with the time remaining, talk about some lift station improvements, dealing with ragging issues, um, how to prevent clogs and backups in the collection system, and increase their operating efficiency overall. So at this point, I'll turn it over to Joe. Joe, feel free to start sharing your presentation, and you can take it away.
Okay, thanks, Sean. Just have a little technical difficulties here getting things squared away on the software end, but I am going to, can everyone hear me okay?
I can hear you, yeah.
Yeah, okay. I'm just gonna try to, it's been a long time since we've used Zoom. We're doing everything with Teams, so I'm trying to share my screen here.
And the chat is confirming they can hear you too, so
Okay.
good on audio.
Whoever Zoom expert, how do I share my screen here?
So top center should be the menu bar, bottom center of your screen should be the Zoom bar. In that bar, there should be a green new share button.
No. View options. No. Nope. No.
Have the ability to share.
Yeah, I don't really hit, there's really hardly any buttons here for me, guys. I apologize. I can.
I have that link to your presentation on the drive link. I can download it on my end and share it for you.
That'll be difficult, as then I won't be able to control it, Sean. Let me sign out and sign back in real quick.
Hang on, before you do that, let me make sure I've promoted you as a host. Yep, you are a host, so you do have permissions.
Okay. Yeah, there's no
There's no toolbars.
see, something that says more down here. Yeah, there's no toolbars at all on my screen.
Okay,
I'm gonna log out and log back in, Sean. Just bear with me.
I can give you permission
Okay.
to advance the slides from my screen. So let me share your presentation here,
All right.
and then I can give you.
Get this thing back.
Let's see, participants. Joe.
I don't have the pointer on this one.
Start a new share. Then. All right, you should have control of the screen now. Are you still there?
All right. I think we got it now, Sean. Can you
Okay.
hear me okay?
Yes, sir.
All right. So today we're talking on wastewater efficiencies in the collection system. We'll be looking at infiltration and inflow, some study approaches, and some mitigation strategies. Let's see, it's not advancing these slides though.
I've got your share from my screen. So you should be able to just click on the
share. I can
Zoom
share
window.
my screen now. So
Okay.
yeah, we'll
do
do
that.
that. Okay. All right, can everyone see that first slide?
We're seeing your presenter view.
Okay. Oh, that's okay. So I got to share a different screen, right?
Yep.
Yeah.
So hidden screen.
New share. Here we go. Technology.
Perfect.
I love it.
We're set.
All right, guys. Thank you for your patience. Today we're going to be talking about infiltration and inflow, some study approaches, best ways to finding it, and then some mitigation strategies. Okay. Here we go. So a little bit about me. I graduated from Northland College with a BS in environmental studies in 1997. I've been working in the wastewater collections industry for 34 years. I'm currently the department manager, I&I department manager for Robinson Engineering. I've got certifications as an IEPA wastewater collection system operator, NASCO, PACP, and LACP, and MACP, and then recently SSI urethane sealants inspector. I'm also involved with the IWEA, Illinois Water Environment Association, and I've been a collection systems committee member since 2018. So what is I&I? I'm sure everyone on this call knows what it is, but we're just going to talk about it briefly because that's our topic today. So infiltration is the water that filters through the ground, entering in through defective pipes and manholes and building connections. Inflow is the water that flows directly into the sewers through downspouts, sump pumps, and catch basins. All right, it's freezing up on me here, so. All right, here we go. Why is reducing I&I important? One, to eliminate pollution from basement backups, overflows, to reduce operating costs at your lift stations. Obviously, treating excess flow at the wastewater treatment plant costs money, so reducing costs at the wastewater treatment plant. And then it can cause emergencies, so collapses, sinkholes. Emergency repairs always cost more than planned maintenance, and to provide an overall improved quality of life. So the major program elements that we're going to be talking about today are flow monitoring, manhole inspection, smoke testing, and dyed water flooding, CCTV inspection, CCTV review, and then preparation of manhole rehab and sewer lining bid packages. So flow monitoring, there's a number of reasons why you should do flow monitoring. Could be capacity studies, billing sites. This is actually pictured a flume site there on the left. So that's a billing site. Pre and post rehabilitation flow monitoring, and then also for I&I investigation, basin prioritization. That's going to really be the focus of the flow monitoring we're talking about today. So some typical flow monitoring goals include measuring and assessing flows in flow monitoring basins that are tributary to a wastewater treatment plant, with the goal of identifying basins with the highest levels of I&I, and then being able to prioritize your next steps for SSES, including smoke testing, manhole inspections, cleaning, and televising. But it can also provide a baseline of where your flows are. So if you did flow monitoring in 2024 for the whole system, you reduce I&I over the next 10 years, you can see that reduction by doing flow monitoring again 10 years from now. Ultimately, the goal was to reduce operating costs at your lift stations, with planned maintenance and at the wastewater treatment plant. So first step in a flow monitoring program is to do basin delineation. Generally, you want to get the basins as equally sized as possible. You can see on this map, there's some green squares, some red squares. Each one of those denotes a flow monitoring basin. We try to pick discrete basins wherever possible, meaning that there's not, 4 or 5 upstream basins flowing into that basin. You'd like to have discrete so you're not doing subtractions on flows. And it seems like it would be an easy enough task, but it never works out as well as you'd hoped. Flow monitoring basins are good size for flow monitoring basins are 15,000 to 40,000 feet. And you generally look for a manhole that has a straight in and a straight out, which helps with the hydraulics for the flow meter. So after basin delineation, the next step is to do your site investigations. Go to those targeted sites and see is the flow, are the flow conditions suitable? How are the hydraulics okay? Is there a safe way to access the manhole to put the flow meter in? Is it in the middle of a busy road? Are there concerns with the atmosphere? Is there H2S conditions? So once you select the best appropriate sites, you fill out a site sheet, document all the information, and get ready to install the flow meter. Here we've got an example of a correctly installed flow meter. You can see the photo on the left at the top. There's an ultrasonic sensor, a down-looking ultrasonic sensor. At the bottom, there's another white submerged AV sensor. It's really important to have redundant depth on a flow monitoring project. That way, if one of the levels should fail, one of the depth measurement fails, you still have the other one. But also when they're both working together, they usually will track really well, and you'll know that you've got a good, accurate flow monitoring site when they're both tracking each other. Getting into the flow monitoring analysis, it's important to look at both dry and wet weather analysis. So on the dry weather side of the analysis, we can establish the diurnal patterns, the daily patterns for flow. The graph on the left shows a green line and a blue line. Green is the weekday flow, blue is the weekend flow. You can see the lowest point on the graph comes at about 4 in the morning. And that's when everyone's asleep. They're not using water. And you see that the weekend flow is about an hour later than the weekday flow. So that means people in this neighborhood are sleeping in an hour later on the weekends. And you can see that from the dry weather patterns. This also helps to establish wastewater production and the percentages of groundwater infiltration in your average dry weather flow. Okay, speaking about groundwater infiltration, generally 20% to 40% of your average dry weather flow makeup can be considered groundwater infiltration. That's typical. Anything above that 40% threshold is considered excessive. So this particular project I was working on, you could see that most of the meters had more than 40%. So they had excessive groundwater, except for this meter 5 that was below that threshold. And then talking a little bit about wet weather analysis tools. In front of you is a hydrograph. If you see the purple bars at the bottom, those are rainfall. And you notice the flow, the sharp peak there is a spike in the flow when we get that rainfall event. That's basically inflow getting into the system. And then the longer drawn out tail of the event is the infiltration. Both are the rainfall derived inflow and infiltration response. But we kind of look at those two independent of one another. The peaking factor is the fast inflow sources. The volumetric inflow is the prolonged response, including both the peak and the sustained high level of flow until flows come back down. Scatter graphs is another way to look at the flow data as it's being collected. Scatter graphs display both depth and velocity data. They're plotted as a curve, and it can help to show the performance of the flow at the site. They can show if there's downstream control issues such as bottlenecks or surcharging. It can also show when sewer overflows are occurring or if blockages are occurring. So looking at wet weather peaking factors, basically wet weather peaking factor is taking that peak that we saw in the hydrograph dividing it out by the average dry weather flow and coming up with a peaking factor. So in this particular case, there was some basins that had a peaking factor of 18. That was the highest for this project, and that's indicated in red on the map, and the lower peaking factors were in green, also indicated on the map. So basins with high peaking factors generally have that high inflow response and are good candidates for follow-up smoke testing. You'll find things like catch basins, downspouts, clean out caps with missing covers, area drains, and such. For all the wastewater treatment plant agencies on the call today, volumetric analysis is another tool used when looking at the flow data. So the highest basin, the highest peaking factor is not always the highest volumetrically. So this particular case, you can see that a further basin up to the north had more volume of excess flow during the rain event. So that was where this particular client wanted to target manhole inspections and cleaning and televising to get more of that inflow and infiltration off the system as it's going to the plant, and that's costing money. Moving into some of the SSCS investigations, manhole inspection is always an integral part. We've created this manhole inspection dashboard that allows us to see real time the photos as they're being inspected. We've got some dials up at the top of the screen that show, as a manhole is inspected, that dial will turn from 0 to 1 to 2 and so on. We can also see all the attribute data collected during the inspection real time as it's coming in. In manhole inspections, we're basically looking at the components of the manhole. Is the cover, is the frame in good condition? How does the adjustment, the chimney, the cone, the barrel, the wall, the bench, how do all those components look? And then cataloging those in the inspection. As I mentioned, we're doing all our inspections now on mobile apps through Esri's Field Maps application. And then that data just pushes right to the ArcGIS online maps that we have, eliminates the days of the filling out the paper forms and you're out inspecting and the paper gets wet, or somebody didn't have the greatest handwriting and it's hard to make out the information at the end of the day. So this allows us to see that data digitally and right away. And people can share it in the office or share it with clients in real time. During manhole inspections, we're providing an inventory of the structures. You're looking at depth, location, type of construction. Are there any structural defects on the manhole? We're also identifying if manholes are missing, buried, or if there's new manholes found on the map. And then where are the leaks occurring, and then documenting those to lead to the right repairs. This is an example of a manhole bench wall leak. We found this one a couple years ago. It was pretty significant. Some other typical manhole inspection defects found are like a bench failure or missing bench, broken and cracked frames and lids, manhole frame offsets or broken manhole frame offsets, and then missing bottoms or a mud bottom in this particular case. Sometimes the bottom of the manhole can get eroded away over time. Sometimes they were just installed like that with no bottom. And then manholes near water. So if you're within the floodplain, there's obviously more of a chance of getting a lot of inflow and infiltration into a particular manhole. This one along the river was subject to flooding. The interior was fine. It had been rehabbed at one point in time, but the exterior was failing pretty badly. So that river would come up, start to erode the outside cementitious coating of the structure, and eventually bricks would start disappearing, and you might have a large inflow source into your system. Some other manhole defects would include the frame adjustment or the chimney area. In Illinois, those are all subject to the freeze and thaw, so they're deteriorating pretty rapidly. Significant inflow can come through those portions of the manhole, and they're usually the first to start to deteriorate. Root growth is another big factor. You can see once roots get in, they just keep expanding out. They keep growing all over the entire structure. And where the roots are getting in, they're allowing infiltration in, and they're trying to deteriorate that structure as well. After your manhole inspection project is done, the next steps would be move into manhole rehabilitation, prepare a bid package, and always provide construction oversight on a manhole rehab job. So this slide is showing on the left is a list of our typical manhole rehabilitation repair types. I don't have them all pictured here, but that's representative of a typical project that we would put together. The top right shows an install gasket seal cover. The next picture below that is an internal chimney seal. Here we have pictured a manhole seal and adjust. Basically, they're taking off the manhole frame, any of the rings, all the components, putting it back together with proper sealing materials, including bituminous mastic rope between the different layers, and then an external chimney seal, which prevents the water from getting into the structure at the top in the first place. Here's a really nice example of a cementitiously coated manhole that was a brick manhole beforehand with leaks through the walls. And now you've got a monolithic structure, half-inch cement coat, 2 of those, so it's almost an inch thick. Next up, we have a epoxy coated manhole. And this is generally recommended when there's H2S conditions in a manhole. So if needed, you can apply a cementitious coat first to rebuild up the walls of the manhole, and then the epoxy coat to protect it against H2S corrosion. Moving into smoke testing. So smoke testing is an effective way to identify large sewer system defects. Where smoke gets out, water can get in. It's usually done during the driest months of the summer when conditions are dry. We'll use dual blowers, which output nearly 4,000 CFM each. That really helps to maximize the airflow into the system and then identify more defects during the study. Because of the visible nature of smoke testing, it's very important that we do notifications. We'll do letters or mailings 1 week in advance. At the start of each week, door notices will go out to the targeted areas, and daily we'll provide smoke testing emails and phone calls to police and fire, as well as to municipal staff, so that everybody knows where the work is being conducted for the day. And then in all that, all the notifications, we have links to our webpage, which provides additional frequently asked questions and answers about smoke testing. Not everybody will read those letters or door tags, so we'll also deploy smoke testing in progress signs in roads coming into the smoke testing area, so people driving in aren't alarmed or not thinking everybody's houses are on fire and don't have to call the fire department. And it's important to have enough staff members on site to handle people's questions, because this is not something that most residents are accustomed to. It's new for them. It can be alarming, and having the right staff members on site can really help the project to go smoothly. Some typical defects on smoke testing include missing clean out cap or cover, a defective lateral. Bottom left is a cross connection between a storm sewer and a sanitary, and then the downspouts sometimes can be tied into the sanitary sewer as well. Just like our manhole dashboard, we've created a smoke testing dashboard, so we in the office can see that data coming in real time, as well as share that with clients and see the photos as they're coming in and see what type of defects are being gathered. I mentioned was the cross connections with catch basins. So a follow-up to smoke testing is tidewater flooding. Usually what will happen is we'll flood the storm sewer with brightly colored green dye, and then we'll TV the sanitary sewer and see where is that dye leaking in. This is an example one we did about 2 weeks ago. And we had a 36-inch sewer plug. You can see dye coming in through the walls, through the wall bench joint. And for any of you that are on LinkedIn, that was actually my St. Patty's Day post last week. So you might have already seen that video if you're on LinkedIn. Next steps after that would be preparing, cleaning, and televising bid packages for any of those who don't have that service in-house. We typically would prepare a bid package and then oversee the TV data being collected, review that, and preparation for a CIPP lining program. Another dashboard we've created is the cleaning and televising dashboard. This allows us to plot the NASCO scores 1 through 5, plot any of the defects observed during the televising, plot sanitary sewer services. So that, is a nice improvement for the GIS mapping. And then while this data doesn't come in real time like our other ones, we can get weekly or bi-weekly deliverables from the CCTV contractor to ensure that progress is unfolding as it should. And then also making sure that no segments are missing at the end of the job. Here we have the CCTV review legend. So different than the NASCO scoring 1 through 5, we will also rank the pipes for lining recommendations 1 through 5. So a pipe could have a high score on the NASCO score, could just be due to a collapse or repair that's needed. That doesn't necessarily equate to a lining high score, but as you'll see through a couple of these next slides, some examples of collapses and infiltration here. So this is an example of a sewer collapse. That one needed a point repair that was dug up and fixed about a year ago. Next one here is some significant infiltration around a service connection. So the recommendation for this one was to do some lateral grouting and then follow up with a CIPP liner. After the TV review is done, that can lead to a sewer lining program. Could be point repairs as well or grouting. We'll rank the defects high, medium, and low priority areas and then provide cost options for the client. So CIPP lining can be expensive. So a lot of times these programs will be multi-year programs. A recent example of a project we did, we gave the client 3 options. The first was do all the CIPP lining for the 3s, 4s, and 5s ranked with point repairs, grouting, and T-liners. That came to about $3 million. Next option was do the 4s and 5s and the point repairs, grouting, and T-liners. That came to about $2 million. And doing just the worst of the worst, the 5s and the point repairs, the grouting, and T-liners came to about $1 million. This particular client had $250,000 budgeted. So the first year is just going to be the sanitary sewer point repairs. And then they'll focus on, the 5s and some of the other things in subsequent years. Cured in place pipelining does provide a structural repair. It is a trenchless technology, so no digging typically required. Now this is a pretty big liner going in, but when they get even bigger than this, sometimes the frame and or the cone section of the manhole need to be removed. When coupled with mainline grouting and or lateral grouting or T-lining, lining can be significant in helping to reduce infiltration and inflow into the sewer. As mentioned, it's important to do mainline grouting and lateral grouting in addition to your CIPP lining, because lining itself won't reduce I&I, but when you couple it together with these other phases of work, then you get a better chance of reducing I&I. Mainline grouting, basically you pull the packer into place, you can air test that joint, and then pump grout out into the soil around the pipe, forming a soil grout matrix, which then thereby seals off the pipe. Seals off the leak. Here's a couple pictures of the same process, but for lateral grouting. T-lining, that's repairing the connection between the service lateral and the main. So the T-liner is a full wrap section on the main line, as you see in the photo to the right. And then the T portion or the lateral portion can extend anywhere from about 1 feet up to 200 feet, I believe, is one of the longest runs. Cleanouts are often installed to facilitate the lining installation as well as future maintenance. So that was a lot in a short period of time. That was a general typical I&I program, investigation, finding and repairing. Sometimes that's not enough. Sometimes, communities or sanitary districts will still have a lot of inflow and infiltration after the fact. So there's next steps that can also be done, including lateral televising programs. So if you do a pilot lateral televising program and you smoke tested, a good idea would be to do those homes that had lateral defects show up on a smoke testing program. It may start to reveal neighborhoods that have problems with service laterals in neighborhoods that don't. Those can be followed up with lateral grouting and T-lining. House-to-house inspections is another one that most communities are not too thrilled about doing, but once you get into people's houses, you can see if they have sump pumps connected, combination sumps, are there diverter valves, and then footing tile separation programs, usually saved for the very end of an I&I reduction program. That can also be part of the lateral televising program, is to start investigating which neighborhoods might have footing tiles and then putting together a footing tile separation program. Private sector disconnection programs, generally, you start with the small, easy to fix stuff, window well covers, clean out caps, disconnection of downspouts. As you move into a phase 2 or a phase 3, you might have disconnection of sump pumps, disconnection of driveway drains, fixing service laterals, or disconnection of footing tiles. That was all the stuff I had prepared, so definitely can open up for questions.
Thanks, Joe. If you do have questions, go ahead and start dropping them in the Q&A. We do have a little bit more to present here on managing solids and handling lift station improvements. So I'll start going through that. My slides up again. So looking at some lift station improvements, one of the most popular is adding VFDs to those lift stations. So you can tune that pump to match the inflow coming in, prevents pressure transients in the systems, prevents slug flows from coming into your plant that can disrupt your treatment process, and it saves energy for the lift station itself. But slowing that pump down, especially on initial startup, can make clogging more frequent. So we've seen some municipalities have removed VFDs because of this issue. We've seen some that have adjusted the settings on the VFDs to set a higher initial starting speed so it can draw through solids without them binding up in the impeller. And that has solved the problem for them. The other benefit that you can get with VFDs is a lot of control panels now can implement clog detection software, and it can implement an auto cleaning cycle where it'll either initially start the impeller in reverse to let loose the rags and then start running in forward operation, or it will kind of jiggle that impeller to break loose any bound materials on it and then allow them to flow through the system without binding up the pump and causing damage. Some alternatives for VFD control. Again, they're an effective energy saving strategy. They reduce wear and tear on the pump itself by reducing the inrush current, torque, and wear on the bearings. But you do have to be careful with them not to exacerbate clogging issues. Setting a minimum speed that ensures draw through of debris is one way to do that. That minimum speed should also prevent downstream settling out of solids in that sewer main. So there's a balancing game to play there between speed control, matching the flows, and ensuring that you're not causing additional issues. And then there are different control profiles. A couple of examples here shared from Xylem's website that are beneficial for different situations. So using a constant wet well level can optimize energy at the pump, but it sends varying flows to the to the treatment plant as speed increases to match the influent levels. Where that's the top chart there. The bottom chart is a variable wet well level where it's working to maintain more of a constant flow rate and allowing the water level to adjust a little bit. The more that water level increases over time, the more that pump is then going to ramp up in speed. And this can kind of give you a little bit of benefit in that you can use your collection system as a bit of a buffer for sending flows to the plant. So there are different control options that can be chosen depending on your needs. If solids are a major issue and clogging is a concern, sometimes we've seen at lift stations, particularly near sites where there is a known source of contaminants coming into the sewer system. You can install grinders to break those solid materials up into smaller pieces. Those smaller pieces can then pass through the impeller without binding and causing issues. It chops up rags so that they're in shorter lengths and less likely to bind up. But there are some potential downsides to just chopping it up and sending it downstream. If you have a particularly long sewer main after that lift station, or it flows into a second lift station after the initial one with the grinder, those rags can reform. Fats, oils, and grease in the system can help those ragging pieces that have been chopped up rebind into a mass again, and then you've got another issue downstream. And at the plant itself, chopping up those smaller pieces may help them bypass the plant screens, in which case now you've got issues in the plant process itself. So sometimes these are beneficial, sometimes, depending on the situation, maybe not as useful out at the lift station. And maybe something like total solids removal using an auger system with a catch basket is a better solution. So shown on the screen here is just a basket screening system. As those solids build up in the system, an auger lifts them out and dumps them into a waste receptacle. Since you're removing those solids, they can't reform into a clog downstream. Helps remove those rags and things, and so that they can't rebind up in the system. You do have to set up some kind of waste collection at the site. You can enclose that basin so that there aren't odor issues. I know that's a concern with some communities. So there are options to help make that a little bit more feasible for the community that's being installed in. And it's a great idea for stations that aren't near residences or communities that are out kind of in rural areas. Fats, oils, and grease that flow into the system that can float on top of the water surface over time will build up in a lift station if it can't draw down enough and clear those floating materials out. And that can lead to issues with clogging, with odors, with corrosion, things like that. So there are lift station designs with trenches in the bottom that can help, combined with a cleaning cycle of the pumps where it draws that wet well down instead of trying to maintain a constant wet well level or a variable wet well level that we saw in the previous slides. And that drawdown will then help suck out all those fats, oils, and grease and floating debris on top of the water surface and get it down where the pump can actually draw it through and get it out of the wet well system. There's various different companies that offer kind of trench bottom wet well systems that have different benefits, different things that they claim. So the one shown on the screen here is the pre-row clean, which also claims that since it's swirling the waters, it goes through the trench. It can help boost the efficiency of your pumps by pre-rotating the flows going into it. There are other systems as well that just have slope bottoms instead of flat bottoms to those wet wells, so that you can draw materials towards that pump where the debris and stuff can be drawn through the impeller and pumped out of that wet well to prevent buildup over time. So those were the quick items that I had. I've seen some questions come into the chat for Joseph here. The first question, what solutions have you seen for service line repairs when the municipality doesn't have ownership of the service lines?
Yeah, thanks for that question, Keith. So I've seen a few different things. That is a challenge because, you know, everyone knows that once you fix your main lines and your manholes, that there's still the laterals, and those can be a problem. So I've seen where communities have taken over more ownership, taken over ownership to the right of way, and then done T-liners to the right of way. That one particular case wasn't enough, and they actually had to then go from the right of way and line all the way up to the home. And that did seal up all those lines in that neighborhood. So that was an option. I know sometimes with easements, backyard easements and stuff, you've got a 10-foot easement. So I've seen 5-foot T-liners be utilized, and municipalities can justify, expending those dollars on that first 5 feet of the segment because it's a backyard. Nobody wants people digging in a deep easement like that. Also seen where, even though the laterals are owned by the private residences, villages have adopted, rules to basically fix repairs under roadways because they don't want just some, fly-by-night plumber digging in the roadway and then ruining that road for everyone else in the village. So we've seen that as an option. I'm working with a client right now on their ordinance to actually, they've fixed all their mains, they fixed all their manholes to work on an ordinance that basically handles the service lateral, does an inspection at the time of transfer. So when somebody sells the house, at the time of transfer, they got to do an inspection, and then they will get a list of repairs, what needs to be done on the service lateral. So more and more communities are starting to think about it and starting to address it. And, I think there'll be some more solutions coming in the near future.
Thank you. The next question came in is for manhole rehabilitation. Do engineering firms normally select one method, or do they have bid package options? And then as a follow-up to that, what's kind of the most popular rehab method that you see?
Yeah, thanks, Justin, for that. So typically a typical project for Robinson Engineering, we've gone out and we've assessed all the manholes in a certain basin. So let's say we've done 300 manholes, and there might be a list of 15 to 20 repairs. That was the one slide that I showed you. That was kind of our boilerplate project where you're going to have cover replacements. You're going to have seal and adjust manhole frames. If the frame conditions are deteriorated, you're going to replace frame and covers. Cementitious is a very viable recommendation and product for manholes that were block manholes or brick manholes and they've got leaks. So that cementitious coating can really be of a big benefit. The seal and adjust, the top side of the manholes is important. Epoxy coatings generally come in where there's corrosion involved. So we're trying to prevent further corrosion when we're recommending the epoxy coating. So we'll usually have a whole list of things on the bid package, and there will be specifications associated with each to make sure the contractor knows what they're doing on each one of those. Polyurea, that's a good example that you throw out there. That was popular in the late 80s and 90s. A lot of those early polyurea manholes failed for the reason that it's hydrophobic. So if you put polyurea on a moist or wet, damp environment in a manhole, it's not going to adhere for very long. And that's what we saw with those. So there was kind of less polyurea going on. I know there's a product out there now that uses a polyurea layer, then a structural foam, and then another polyurea layer. It's a good product, but prep is key. So you want to make sure that manhole is bone dry before you put any polyurea coatings on it.
And then John asked if you could share the ordinance who's requiring that inspection ownership, share the community that has that.
I'll have to get permission on that. It's still a work in progress, but yeah, once they say green light, go ahead, I'd be happy to.
Yeah, John, follow up with Joe. His email's on the screen there. Once
Yeah.
he gets permission, he can follow up with you.
For sure.
One thing I've run across in doing assessments and stuff with plants, we had a community that had started doing I&I abatement and had actually increased the flows coming into their plant from the projects that they were doing. Is there an order to the projects to prevent having issues like that where you're actually increasing flows coming to the plant?
Yeah, that's a good point, Sean. And I've seen that as well. Where you go in and you start doing all this lining and you're just doing lining. What ends up happening is you get the I&I at the plant faster because now you reduced the friction in those old pipes where there was roots and there was sediment and there was debris and there was breakages, and now you've got this nice brand new liner in there. So the I&I is getting there quicker. And if anyone who's worked in this industry long enough knows, you fix one leak somewhere, it's going to migrate to the next open spot. So that's why with doing CIPP lining You want to do some grouting. You want to couple it with manhole repairs. You want to do private sector investigations and private sector disconnections. You want to do some T-lining if possible, if that's feasible. It's really, there's a lot of tools in the tool belt for it, and you can't just do one or two things and think that we're done. It's really an ongoing effort. MWRD has a long-term operation and maintenance program for their Cook County communities, and they effectively have to do 2% inspection every year and then repair any of those defects. So that's, basically a 50-year cycle. They want every community to get through their entire system. Some communities might be on a 20-year cycle. I saw one of the questions was, how long does the manhole liners last? A good cementitious liner, you could expect 20, 30 years out of that, but eventually water and roots are going to win, and they're going to take over again, and you're going to come back to that manhole that was repaired 30 years ago, and it's going to need, maybe some touch up, maybe some more attention at that point. So, a lot of communities have thought over the years that, oh, we did that one. Oh, we did that one back in the early 90s. Well, it's time to look at it again. So we're 2024. So you got to keep looking at these things and keep sealing them off as best you can. And as far as the order of operations, definitely, lining, doing the manholes, then working your way into the private sector is a good plan.
Okay, I don't see any other questions that come into the chat or the Q&A. I would like to remind everyone again, we've got a few slots left this program year for our no-cost energy assessments. So if you're interested in those, please do reach out to me at the email address on the screen or find the application link at the website address there. Joseph, thank you for all the helpful information and for helping us out with the presentation today.
Yeah, thanks a lot, Sean.
All right. Everyone else, thank you for joining us today. Hope you have a wonderful afternoon.